I will talk a bit about DLSS today. Are you aware of what DLSS is, or have you heard of it before?
No, I don't think so.
Okay, so DLSS is tagged by Nvidia. It stands for Deep Learning Super Sampling, and mostly it is used for, or it is a technology used for gaming. Basically, what it does is it will render the game at a lower resolution, and it will upscale that frame using AI. So it's like a very bare bones definition of what DLSS is. I'm talking about DLSS because recently, few weeks back, or I think maybe a month ago, they unveiled DLSS 5, so the fifth iteration of DLSS. So before you talk about that, maybe you can go through all the different versions of DLSS so far. We will watch some videos, but I'll try to summarize what those are. So DLSS 1 came out around 2018. It was mainly AI upscaling, but so like I mentioned, it will render the actual frame in a lower resolution and use AI to upscale it to a higher resolution. But in DLSS 1, the main limitation was that this model had to be trained for each game. So there was no generic implementation. Each game had to manually train DLSS to work. Then in 2020, DLSS 2 came. So it works across all games and it did not require any manual training per game. So, and there are like minor improvements, images were more stable, sharper, etc. And it used technically, the technical term would be it used motion vectors plus past frames. Meaning in DLSS 1, you will have a particular frame and you will upscale it, but you will have no knowledge of what the previous frame was and what the future frame is going to be. So you don't like if a person is moving it in a particular direction and you stop the frame, the LSS 1 had no idea about the intent of the person moving, but LSS 2 had that understanding. So it was able to upscale it better because it had those kind of information as well. And then DLSS 3 came around 2022. It made some improvements to their upscaling technology, but the big change or big update to DLSS 3 was AI frame generation. So you will have frames rendered by the GPU, the hardware itself that is in the machine. And between each actual generated frame from the machine, you will have frames that are generated by AI that is not actually generated by the hardware. So you are getting more frames while the hardware is not working as hard. So you're able to get what I'm trying to say, right? So the actual
Yes.
frames, so suppose there are two frames, using AI, you are adding two more frames in between.
Okay.
So it is basically it understands the scene and everything, and then it predicts what the movement is going to be and adds that frame. So you're getting higher frame rate basically. But yeah, that also introduces input lag because as you are moving the mouse and the mouse, suppose the mouse should have moved two frame, but in between I'm adding additional two extra frames that the hardware or the mouse did not anticipate to be there. So in some games there might be some input lag. It's not major depending on the game and implementation. It was manageable, but yeah, that was there. And then DLSS 4 came around last year, so it adds multi-frame gen. So DLSS 3 could only do two times the frame. Multi-gen, I think it has the options of four times the frame. So and ray reconstruction as well. So ray tracing was technology in graphics. So I don't know if you know of what ray tracing is. Do you know what it is?
So can you just explain it like in simple terms so that
Ray tracing, before ray tracing, how the lights would be rendered in game is my, I mean, my understanding is that they would be there is no actual physics involved. So, for example, there is a scene where there is a light is turned on in the ceiling, and that light is reflecting off the floor. In reality, if there's a light and there's some water in the floor, you will have the reflection of the light, and the reflection of that light from the ground will be also in the walls, etc. Right? So there will be a cascading of reflections from one source. Previously, that was rendered, or it was from my understanding, it was like hand animated, you could say. So the computer was not calculating in real time where the light rays will go. Ray tracing will trace the actual light in, like in the sim, in the game engine, from the source of the light to how it should bounce, be based on the physics, how I've defined the physics. So it is not, so it is real time. You are not deciding, or you are not giving a direction, means you are not scripting the scene based on how the actual world changes. The ray or how it reflects will also change. So that was ray tracing, but it requires like it is a very heavy computation for the GPU to do. Even now, only most high-end GPUs can properly do ray tracing. So then comes ray reconstruction. I don't exactly properly understand it. My understanding is similar to frame gen. It will also do ray reconstruction, but AI will figure out much of the physics or the calculation by itself and just do it. There is like a very higher level understanding and some other improvements as well. But then came the announcement of DLSS 5 this year. What it is it's a real-time rendering model is what is mentioned. So I think seeing it would be better to understand, but I'll try to explain. So far, first was AI upscaling the frame from lower resolution to high resolution. Then AI was adding frames in between. Now AI is rendering, or it is taking the entire scene and adding stuff that is not actually there. It is generating the frames, or it is rendering the frames itself. It's maybe not the best way to explain it, but I'm just trying to see if I can explain it or not. But it seems I'm not properly able to. So it is like a filter that has been added. If you maybe I think we should just see some of the demos. It'll be much easier to understand.
Okay.
Just a minute. So maybe we'll see one of these announcements. Uh, yeah. How do I stop sharing? Actually, I don't know. Oh, okay. So you're able to see like what they're trying to do, right?
Yes.
So it completely changes, or it enhances the entire scene.
Okay.
So maybe I'll find few more examples because there are multiple. Mm, yeah. So that was some demos. So far, like all the up to DLSS 4, the announcements, whatever, people would like more or less happy with it because it actually enhanced their experience and stuff. But with DLSS 5, can you guess what kind of reaction people might have after seeing the demos?
Why was it not positive?
It's not entirely positive.
Why?
Mainly, people are calling it like AI slop because you see, like they will have a certain facial reaction or facial art to them, and once the AI filter is applied, like AI has done this thing. If you check the before and after, it seems one of those AI generated
Images.
images.
It is. Okay.
So people are calling it. There's actually some this term yassification or something. Basically,
Gasification.
yeah, it's like a slang term. So
Okay.
basically, you have a person who looks who is a normal looking person, and you are enhancing with AI, and the AI makes it like completely unreal or like a model like or something like that. So it gives those kind of
Yes.
features, that
Yes. Yes.
exaggerated features. So that is the main reason, and some are talking about like artistic intent. So if a developer decides they want a character to look a certain way, and this AI is changing that entire direction and stuff. Uh, but it has not been released publicly. It is just a demo. And I think immediately after the reaction, Jensen Huang was also doing some PR stuff saying it is not what people are thinking and stuff. But that is besides the point. Maybe we will go through some videos to understand DLSS in some more detail. Just look at this.
With DLSS 4.5, it's got some new and improved models. The Nvidia app lets you override game settings so that you can use these newer models, replacing the older ones which were included at the time. Or you can use older models if you do so wish. I will compare a bunch of them in this video. DLSS upscaling is getting complicated. We started with DLSS 1, which was in games like Battlefield 5, and it sucked ass. So much so that AMD just invented FSR to counter it, which was essentially an edge smoothing tool with a bit of sharpening. Nvidia then created NIS, which was pretty similar to FSR, which looked similar to DLSS 1. Got that? Good. But then Control rolled out what I'm going to call DLSS 1.9, which was significantly improved. And that's really when the world woke up to just how powerful upscaling could potentially be. I thought it was a miracle technology at the time, but it was still just using normal graphics card cores to do it. But then, for DLSS 2, Nvidia finally moved their upscaling over to their neurally AI tensor cores, and that was probably the point where AMD shat themselves, realizing that their FSR alternative wasn't going to cut it anymore. And so, looking on the Nvidia app, even this earliest Model A variant of DLSS is still some variant of DLSS 2, so it's already quite good. But these models should hopefully get better as they go along. But it isn't that simple, because some of them are more optimized for different amounts of upscaling. Model F, for instance, is optimized for ultra performance upscaling, where it makes 9 pixels from every one, whereas Model E is better designed for performance mode, which makes 4 pixels from every one. All of these model letters are the old CNN style of upscaling, whereas from J onwards they move to the transformer model, which is super sophisticated, graphically superior, but will slow down older generations of RTX cards more significantly. Straight off,
Okay, I
let's
have
compare
one
the
question here.
newest.
Yeah,
That's CNN, that means, is he referring to
yeah,
convolutional neural networks?
yeah.
Okay,
That is what they're using.
okay, okay, you can continue.
The top is preset A, and on the bottom, the newest transformer-based preset M. And if you ask me, even preset A looks pretty good here. I decided to test 1080p performance mode because YouTube isn't the greatest for these sorts of comparisons, so having such a low resolution should at least make the differences more obvious. And there are some, but to make them more obvious, I'm going to have to slow this footage down more and zoom in further. In fact, screw it. Let's just do a still comparison, and the newest Model M is much sharper across the whole board. Sharpness on its own doesn't mean more detailed, but zooming into details like the Brosif barrel, I think
I don't know if you're
everyone
able
would.
to see it clearly through the screen share. Can you see the difference between whatever he's trying to show?
No, can you just go back like 10, 15 seconds? Let me see
that
it again.
ETLM is much sharper across the whole board. Sharpness on its own doesn't mean more detailed, but zooming into details like the Brosif barrel,
Like
I think
here, it was quite evident before and
Okay.
after, but
Okay,
maybe
this
it's
part
less.
now is this the before or is this the after? Before. This is before.
This is the after, I think.
Okay,
Yes.
that because yeah, this
on
was
its own
yes,
doesn't mean
this
more
part
detailed, but zooming
So
into
this is
details like
the
the
before.
before. Okay.
Brosif
Yeah,
This is
barrel,
the
I
after.
yeah.
think everyone would agree that how Model M does it makes it look better. Same with the newspaper on the floor. It just looks like it's a higher resolution and without coming with any extra artifacts that you might expect from extra sharpening. So the upscaling must be better. And further proof of this comes from the exit sign, which is now a lot more readable, which is very important if there's a fire. And also, whatever the hell these hanging down things are in focus with Model M, and out of focus with A. On the door, the old Model A shows obvious dots or lines going across it, which comes from the lower resolution it's trying to upscale from, whereas Model M almost completely eradicates this artifact. In short, Model M does a far better job of faking a higher resolution than it's actually rendering at. You're not supposed to use really aggressive forms of upscaling like performance mode when you're only gaming at 1080p resolution, but with how good these transformer models are becoming, it might even be getting to the point where you
Wait,
can get away
this
with using
person
it here.
changes. Can you go
I
back
don't want to
again to that
Yeah,
person
I saw that.
changing? Almost change the color
This
also
one, right?
should have. Yes.
gaming like performance mode when you're only gaming at 1080p resolution.
Changes the
But with
clothes
how
as well.
good these transformer models are
Yes.
becoming, it might even be getting to the point where you can get away with using it here. I don't want to pixel peep too much, so other things I want to note from this run are the big pixelated looking clouds and smoke effects, which as far as I can tell look distractingly pixelated no matter which version of DLSS you use. A product of upscaling that science is yet to remedy, but who knows what DLSS 5 will bring. And the big distracting problem with older versions of DLSS tended to be these traily, grainy lines behind moving objects, which you can clearly see here behind the palm tree trunks just here for Model A, which with the new Model M, it completely removes, showing the increased intelligence of the transformer-based models. Nvidia tends to show them doing a better job with particle effects, which again
Here, I think he's talking about ghosting. Can you see some difference here?
Yes.
So,
I
like
mean,
the difference or the clarity of the tree itself is more sharper here. Here, it kind
yes, it
of
is.
it is jagged at the edge. So this kind of I think this kind of art situations in gaming it's called ghosting, where a
Okay.
certain thing is rendered when it is not there.
Okay.
the older models do a bad job of, either making them look traily or just doing away with them entirely. You thought that comparison was fun? Well, now I'm going to do it again, this time using Model B against Model L, being the oldest and newest models optimised for ultra performance upscaling. This is where the upscaler tries to make 9 pixels from every one it's rendering. This is rather challenging and was intended to be used at high resolutions like 4K and 8K, not 1080p, which is what I'm doing here. So this is a real challenge for them to render the scene convincingly. Again, I don't want to get too bogged down with all the details, but for
Also, when you're talking about upscaling, so like the main point here is that we are seeing 1080p.
Okay.
The image visible to us is 1080p, but the GPU is rendering at 360p.
Okay. So what does
So
it
that
mean?
is the meaning the GPU has to do less. So like rendering higher resolution is difficult for the GPU, right?
Okay. Yes.
So the GPU is actually rendering at 360p. Then everything is upscaled by AI to 1080p. So it looks like 1080p to the eyes of the human,
Okay.
but to the hardware, it is only running 360p. So that is why the upscaling tech is being used. So this is
Okay.
the
So it's,
ultimate performance. So you mentioned it's written in ultra performance. Before that, it was just performance.
hmm.
So it was the GPU was rendering like 490p or something, and
Okay.
that was being upscaled to 1080p. Ultra performance is when the GPU is rendering only at 360p, but it is being upscaled to 1080p. So it is not supposed to be used this way,
Okay.
mm, because that is not the best way to use it. The best way is like you are actually the GPU is rendering at 720p or 1080p, and then you are upscaling it to 4K. So those kind of scenarios it makes more sense. This is just for experimentation to find out the obvious difference. Here is doing this.
Okay. So the one on the right is done by transformer model, and the one on the left is done by the by
So
CNN.
model A or model B to model L is the transition from DLSS 1 to DLSS 4.5 here. So this is the latest one.
Okay.
This was the first one.
Okay.
Fortunately, there aren't many details to get bogged down by here. Model B makes the wall covered in writing B rubbish, and once the mesh goes in front of it, the writing really is on the wall for the older model, which really can no longer manage the writing on the wall. And the neon signs are a mess too. It's not like you should expect great results here, yet the transformer model comes out on top by a wide margin. Even after this mesh bit, check out how clear the writing is using Model L. The old model is just JPEG'd up in comparison, you can't read the writing at all. And look at the bottles on the table, you can see ghosting behind them using Model B. But again, Model L takes it all in its stride. Look at how shimmery and unstable the old model is on the details in the distant bar. This new model isn't like that at all. You can even read the spunky monkey sign, and it just looks more like a video rather than a series of flashing pictures. So what are the limitations with this new model? Well, if we go nearer to the end of this scene, you can see it's still flickering a bit around the edges of fine lines on the palm trees. But remember, this sort of upscaling was never designed with 1080p in mind. The fact that it's edging it towards the realm of feasibility is a small miracle, and it's no longer an unpleasantly shimmery, horrible experience. Hopefully you're never in a situation where you have to use ultra performance upscaling at 1080p. But there might come a time, sometime in the future, when you might not mind having to, provided upscaling becomes good enough. So that's a leap from DLSS 2 to DLSS 4.5. But what does the leap from 4 to 4.5 look like? This. I was expecting the transition from transformer to transformer upscaler to be minor, yet I was shocked to notice so many meaningful differences. Shocked, I tell you. And that's just when previewing this video in my editing program. 4.5 is noticeably sharper across the scene and more stable, like how you can read Spunky Monkey. How much better can it get beyond this point? Will they introduce an ultra performance mode where it's rendering at like 240p with still excellent results? Some of this might be a product of preset K being a first attempt at transformer based upscaling, so maybe it was a bit rough around the edges despite being built on much better foundations. Now let's compare the two transformer models in performance mode. And I found the differences here harder to spot, given that there are random smoke spots every run, which makes it harder to compare like for like. I would put this down to Transform being powerful enough to make 4 pixels from every one pretty well already, so we only really see the improvements when we drop down further to Ultra Performance mode, where there is still significant progress to be made. I haven't really touched on frame rates until now, but the new 4.5 models are meant to run slower on every graphics card, so it might be worth sticking to the older DLSS 4 model if you're running it in performance mode, and then only switching over to the newer 4.5 model if you're going to be using Ultra Performance mode, where it can still yield significant improvements over older models. But even at performance mode, I felt like the newest model made the bottles at the bar appear to flicker more, I think. Is that a bug? Or is that how it's meant to be? To find out, the latest DLSS performance model versus downscaled 4K DLAA footage to get a ground truth for how things are meant to look. And I think the latest model does a great job of holding up to how it's meant to, despite me comparing 540p against full 4K here, which will look right just by brute forcing lots and lots and lots of pixels. DLSS makes it maybe a bit brighter and more contrasty, and the bottles at the bar are doing something weird. They all seem to imitate each other's reflections in a way that the 4K version does not, so I'm not quite sure what's going on there. Maybe the lower resolution is playing a part in some way, but who knows. So maybe there is still some way for upscaling to go before it can fully replicate a perfect image. But you know the one big difference between these two? The frame rate. That's right, rather than nitpicking visual differences between the two, just bear in mind that one is running 4 times faster than the other, and even then it's probably just CPU limited. In conclusion, these new models look beautiful and are visually superior to older models. But whether they're worth the extra performance impact they come with, and by performance there I mean frame rate, not the name of the upscaling setting, remains to be seen. And now, the final challenge. How do these models fare with full path tracing? On the left, the oldest preset, on the right, the newest. Using ultra performance upscaling to try and make sense of full path tracing. Wait a second, Philip. You're telling us this whole video up till now has been done without ray tracing on? Why would you do that? Surely that was the whole point of DLSS existing in the first place, in order to make ray tracing actually run feasibly fast in games. And you're right. Problem is, DLSS 4.5 doesn't currently work with ray reconstruction, aka a component of DLSS 3.5. Without it, you can see the shimmery mess on these shiny surfaces here. Ray reconstruction helped to calm this sort of effect down and to make path traced information on thin and awkward.
So here I think different implementation of ray tracing and ray reconstruction. So you can see, like as you go towards the right, the reflections start to look more real and more real time.
Hmm.
And not
surfaces.
only that, this DLSS is also making sure that the frame FPS is higher as you go. So the lighting is better, plus the FPS is also higher. So that is one thing to note here.
Appear more consistent over time. Without it, even DLSS 4.5 suffers from distracting artifacts that complicate this analysis. But if you try to turn ray reconstruction on, then it overrides DLSS, which is a bit of a problem with this sort of testing. I just don't feel like DLSS 4.5 is truly finished just yet. We're not seeing it at its full power. So with this video, I've instead tried to focus on the aspects of it that are done, because otherwise there are too many variables to factor in, without the fear of another option overriding the aspects that I'm trying to compare. But you bet, in ray-traced and path-traced situations, these are where the true benefits of the new transformer models will really come into their own, in trying to clear up a low-res, smeary, mushy, dotty, spotty, path-traced mess. Let's just stop and see how far we've come. Back in 2019, nobody believed in DLSS upscaling. It was mocked, and when FSR's sharpening filter came onto the scene, even experts like Hardware Unboxed proudly declared that DLSS was dead, stating that sharpening filters were the future. Admittedly, it looks as though they've since added DLSS 1.0 to the title to try and disguise this, but I think it's pretty clear that people back then didn't believe in the technology, and that in the years since it has revolutionised the scene. And DLSS 4.5 is but the latest version, and I doubt it will be the last. So until ray reconstruction supports this latest version, stay cool, be fresh, and smash that sub button.
Okay, so there was just some comparison, and towards the end he made some comparison with DLL and stuff. I also don't understand it completely, but I think it gave a decent overview of what DLSS technology is.
So one thing,
yeah,
just briefly, just the one thing that you mentioned is that you said that this thing isn't done by the GPU. So where does this computation happen?
no, the computation happens in the GPU, but there's a difference between the GPU rendering the calculations to create the frames. Actually, this part is also one of my confusion. I don't understand it completely, because at the end of the day, the GPU is the one doing the computation, but it's not doing the graphical computation. It is doing, it has a model that will, I guess, running the model to generate fake frames or fake upscaling is less heavier on the GPU than natively rendering the entire scene in that resolution. Maybe that could be the reason. That is actually one of the question I also have.
Okay.
But I think it is about balancing, because if you want to natively render 4K, then it will be much heavier for the much more expensive or hardware intensive task. Whereas so you're running it and rendering it at 1080p, then you're using some AI models to generate upscale it to that 4K. Maybe that process is less intensive to the hardware. And as you mentioned, somewhere in between, it uses specific cores for AI computation now. So DLSS has 10, I think, Nvidia calls it tensor core. I think it is tensor for all the chips, but yeah, so there is the graphical core which renders the graphics, and there are tensor cores which does the AI calculations. So having this differentiation maybe makes it more efficient. But that is a question I'm also not sure. But there's actually
Okay,
one more
you can
video.
continue.
This one is, I think, specifically more on DLSS 5. But let's look at it.
Okay.
DLSS 5. So Nvidia showed DLSS 5 recently. They've called it a next-gen leap, the future of gaming. They said it'll let artistic style shine through, and that it's definitely not AI slop. Meanwhile, gamers saw it differently. The memes have actually been very good this time around, and companies hate memes like this. But before getting into all the DLSS 5 stuff, let's just do a quick history of DLSS. Starting with what is it? It stands for Deep Learning Super Sampling. Deep Learning essentially just means AI, and the super sampling part is actually a lie, and a better word would just be upscaling. So it's essentially just AI upscaling, because super sampling would be rendering at a higher resolution, and then scaling down to your display resolution. This gives the best image, but it's the most expensive for a GPU, whereas upscaling is rendering at a lower resolution, and then AI fills in the rest, which makes games easier to run. So in 2018, they released 1.0, and this worked on a per game basis. They had to train it on each game. Then in 2020, they released 2.0, which was a generalized AI. This is where it could work on any game without this huge training thing. And then in 2022, they released 3.0, which introduced frame gen. If I understand it correctly, this gives you one AI generated frame for every frame that you create. In 2023, with 3.5, they introduced ray reconstruction. This has to do with lighting and ray tracing and all that. In 2025, they did 4.0, which changed it to a transformer-based AI, which I guess is more like the LLMs. And then in 2026, they announced 4.5, which is supposed to give you 6 times frame generation. I gotta say, I'm not like a huge settings guy. I usually just get my game running at the highest frames and then move on. So some of this stuff is kind of new to me, but I'm obviously very interested now given what DLSS 5 is apparently trying to do. So let's get into that. In 2026, they announced DLSS 5. And apparently the big difference here is neural rendering. This infuses the scene with generative AI to create photorealistic lighting and textures. And it's worth mentioning that they use dual 5090s to run this demo. I'll show some of the stuff on screen right now, but I'm pretty sure most of you have seen it by now. I think the actual characters look like they came out of a Gen AI prompt. And at first I was thinking that maybe this would work best for just environments. It was actually this clip from Oblivion Remastered running it, like the photorealistic buildings, like that was actually kind of cool. And then it all came crashing down because Daniel Owen made a video where he got his questions answered by Nvidia. So he starts off by saying his biggest question is it taking a single 2D frame as an input and creating the output frame. Now this obviously does include motion vectors, which just means that AI is supposed to know what direction the characters are actually moving for the next frame. And Jacob Freeman, who I guess is a rep for Nvidia and is the one answering these questions. By the way, the Nvidia logo is purple because I inverted the colors to make these dark mode. And you can see to Daniel's dismay, Jacob said yes, DLSS 5 takes a 2D frame plus motion vectors as input. Now this has wider implications that we'll get to in a second, but first Daniel clarifies that the geometry.
Also, some of the things like they're mentioning here, I'm also not very sure. Like, why are there like the importance of the question of asking, are they taking 2D image and motion vectors and stuff? Those are some maybe technical reasons why it matters, but I also don't understand it completely.
Okay.
And textures are unchanged. He asks, is the model aware of things like 3D geometry, 3D depth, or is it essentially just looking at a 2D image? And then
Yeah, so maybe because the scene is in 3D. So the AI has to understand the three-dimensional aspect of the image that it is upscaling or it is changing. So it has to understand the difference between the distance between two things, basically a 3D environment. But maybe like he asked, is the input to the AI 3D or 2D? And I think Nvidia has confirmed that it's 2D.
interpreting it similar to taking a screenshot of a game and asking an AI model to enhance the screenshot to make it more realistic. So he's really trying to get to the bottom of if the AI is aware of the game world itself. Like in the single frame, can it actually see like a countertop as a flat surface? Does it know where that flat surface begins and ends? Or does it just have the perspective of wherever the frame is pointing at? Well, Jacob answers by basically saying it is all analyzed by a single frame. So it only sees each frame at a time. Now this screenshot is Nvidia clarifying what developers have control over. You can see they have control over intensity, which as far as I can tell is just like a 1 to 10 scale. Developers have control over color grading, and apparently they can mask off certain objects for the tool to not touch. So all of this matters for this really long question, which I'm going to try and summarize. So Daniel is basically observing that with DLSS 5 on, while she does seem to have a more photorealistic lighting and skin, it also looks like she's wearing makeup that was not present in the original version. So his question is, can developers actually control anything about the output image besides color grading? And what I feel like he's trying to get at is it a 1 to 10 scale? Or is there fine-tuning control like adding makeup? And Nvidia basically responds saying developers will have detailed controls such as intensity and color grading. So nothing about the makeup yet, which is really the crux of Daniel's question. Nvidia's rep goes on to say artists can use these controls to adjust blending, contrast, saturation, and gamma, and determine where and how enhancements are applied to maintain the game's unique aesthetic. Developers can also mask specific objects or areas to be excluded from enhancement. So it seems like it's either on or off. Like you can mask off the character so that the AI doesn't touch the character and only does the environment, but then that would look super weird, right? Like if you had a video game character within a super realistic environment, I don't know. It does kind of feel like it's all or nothing here. Unless maybe you just use it for realistic fire? That could be cool maybe. But yeah, it seems, and if it's on, then it's a 1 to 10 scale of intensity. The Nvidia ref continues to say, we continue to talk to developers to understand all the ways they would like to control the technology. Ultimately, we see DLSS 5 as a tool for them to achieve their artistic vision, rather than be limited by the capabilities of traditional real-time rendering. And it is impressive tech. It just looks bad right now. But then Daniel asked a really important question. I'm so glad he's smart enough to think to ask this. He says, is the model limited to screen space? Or does it have any awareness of the environment outside of what is visible in an individual game frame? Like I said, I see this as hugely important. And the answer is DLSS 5 only takes the rendered frame and motion vectors as inputs. So it just doesn't understand what's going on in the game world outside of the individual frame. That is not how I hoped it would be working. That really does make it seem like just an Instagram filter. I'll also just mention real fast that Daniel pointed out this discrepancy. You can see with DLSS 5 on, the AI just kind of added hair to the character. And the ref's response to this is that the underlying geometry is unchanged. And it's also worth mentioning that this is a very early preview of the tech. I kind of have a problem with this answer. It releases this fall. So what, 5 to 6 months maybe? Doesn't it seem like it should be in the final stages then? I'm not a tech developer, so I don't know, I guess, but in my opinion, they thought it would be the next big thing, and now they're calling it very early because of the reception. I don't think they would have demoed it like they did if it was very early. There's a big debate about artistic intent when it comes to this, and so I have a question. If you could change the entire graphic style of a game, would you? Like if you could make Requiem look like Zelda, or make Zelda look like Requiem, if DLSS 5 could do that, would that be cool? I mean, is it that far removed from modding? Something else is like, do we know what they actually intended versus what was possible? Like maybe Capcom wanted Grace and Leon to look like photorealistic. But then what about Grace's actress? And Leon's actor, I guess. I don't know why I didn't write that down. But did she intend to be photorealistic in the game? Like, is that what she signed on for? How much of her likeness did she intend to be in the game? I gotta say, I'm generally on the side of consumer customization. I mean, people modded Shrek into Requiem like the day it came out. Did the Requiem art team intend that? Did the people who made that? I think mood lighting is actually the main issue when it comes to artistic intent. Like if devs intend a hallway to be dark and spooky, DLSS 5 could ruin it. I see this as an incredibly valid complaint when it comes to artistic intent, but I see a lot of people saying if they wanted photorealism, it would have it to begin with. It's just really hard to know. Like native photorealistic graphics are really hard to do. We just don't really know what's compromised versus intended. I do actually think the bigger thing is artist employment. Like can DLSS 5 fully or at least almost fully replace artists? Like if you have 10, could it replace 9 of them? I mean, obviously not right away, and especially if this only works on Nvidia GPUs. But if AMD comes out with something similar and this is like the new standard moving forward, then this could be a real issue. And then there's the question of, will smaller teams use this to create photorealistic graphics instead of hiring artists to create what would have been normally more gamey looking graphics? Of course, will AAA studios attempt to use this exclusively when it gets better. A lot of them will certainly cut any corner they can, so real quick, I do want to point out the flaws in the demo. This includes the soccer ball artifacting and the player losing his arm and hand, and this breakdown comes from Gamers Nexus. He does an infinitely better job of explaining it than I ever would, so I'm just going to show a clip from him.
Was in the EA Sports FC demo, in which we found several extremely apparent examples of artifacting and ghosting. Limited frames to analyze means we have limited frame-by-frame analysis, but we still noticed a few things. Here, the soccer ball artifacts heavily for several consecutive frames as the player kicks it into the net, even momentarily turning the player into Roger from American Dad, or if you prefer, Fivehead from Twitch. As the soccer ball enters the goal, it loses a spot in the net, bifurcates into two reality distortion balls momentarily, and then briefly vanishes before falling out of the net. We guess the artist's original vision for this was holodeck soccer. When the player runs off to celebrate, DLSS cuts off part of the player's left arm. That's gotta be a red card or something. It produces major artifacts above the player's right arm, and overall just struggles with the character's outline.
So yeah, you can see this is clearly not ready. It wasn't even ready to be demoed. Like, how can Nvidia be a $4 trillion company and they can't pay someone to find these flaws first? But yeah, they intend to release it in a few months, you know? I do have some questions about this, like, does DLSS 5 still help lower-end GPUs' performance? Like, that has been the whole point of the tech up until now. So is it just for this yassification, or is it also gonna still help GPUs? What does AMD do next? Will it be similar tech, something else? Who knows? When Nvidia CEO was asked about the backlash, this is what he had to say.
Since DLSS 5 was revealed yesterday, there's been a pretty vocal response from some of the gaming community that the technology appears to make their cores homogeneous or show only Nvidia's view of how games should look. How do you feel about that criticism?
Well, first of all, they're completely wrong. The reason for that is because, as I explained very carefully, DLSS 5 fuses controllability of geometry and textures and everything about the game with generative AI.
So he just says we're all wrong, and then he goes on to explain how we're all right by saying it's generative AI, and that's what we've been calling it. And yeah, it's just a whole can of worms now that wasn't open before, but there's definitely no closing it now. Like, Nvidia is going to move forward with this. But yeah, thanks for watching. Leave a like if you enjoyed. If you want to buy a mug, they're linked below.
So I have nothing much more to add. Basically, do you have any thoughts regarding all this?
Okay, like from the technology point of view, I want to get a broad idea about what it's trying to do and what the newer versions of technology is built upon, which is transformers. So that's what I understood. And again, so what I've understood its use case is for computer graphics for video games currently. That's the main use case of this technology. Correct?
Yeah.
Okay. And so when you first showed me the before after scenes, to me that thing about AI didn't come into mind. I simply thought that okay, it definitely looked better. And one thing that came to my mind was that their faces were becoming more shinier, like not just the faces or the whole environment in general became brighter and shinier. That's one thing that I found. But apart from that, for most of the things, I didn't looked it to be very much AI generated kind of videos. Although now that people have mentioned it, now I think it now I can see it a little bit.
I mean, people who have been nitpicking it maybe have observed things. We have just looked at it for a few seconds.
Yes.
Plus, they mentioned, like the original intent of the game was to look a certain way,
Okay.
and with that filter DLSS 5, it is changed. And how much control does the game developer has to how much it changes? And in one of the videos, he showed an example of the environment. So I think where he showed like the medieval town, and before it looked okay, but after it looked quite photorealistic. So in those scenarios, maybe if it is implemented well, it could be done well. But for faces or expressions, those kind of things, maybe we have to see. But I think one point I did not mention, or none of the videos mentioned, was, or I've been seeing this argument that since Nvidia has started focusing on DLSS, like before DLSS, their main upgrade to each graphic card was its raw performance or how much compute it can do. But ever since they have started implementing this AI upscaling thing, they have stopped focusing on improving the raw performance of the hardware. With each
Okay.
iteration of the hardware, they are mainly focusing on how much they've improved the AI, how much the AI can generate fake frames, give you higher performance and stuff. But the raw, I think the term is called rasterization, where the actual GPU is rendering the graphics. So that was how it used to be. So the GPU is doing the whole hardware calculations for the graphics. But since ever since they've started focusing on DLSS, all the improvements they will show, like for CPUs, mm, performance of a phone, people who do the before and after comparison, right? They will show this generation is this percent faster than the previous generation. That was all actual hardware improvements. In this case, how Nvidia started showing was that before you could generate, before the game would perform at let's say 60 FPS, now with AI you're getting 100 FPS. But the actual restoration, like the actual hardware capacity is still the same. The extra FPS is because of the AI, not because the hardware is improved.
Yeah.
So that is one of the criticism, that they are mostly focusing now on implementing this DL AI technology and not really improving the hardware capacity of the graphics card. So they are doing a lot of improvement regarding in regards to AI training and the GPU for AI, like Blackwell and stuff. But their focus has shifted from heavily shifted from consumer gaming graphics card to data center
Okay.
enterprise graphics card. And this entire gaming and DLSS thing is like an afterthought for them at this point.
Yes. So, broadly, this trend is happening everywhere, like the focus on uh, AI kind of use cases as compared to for every company right now, like they're focusing all their energy and efforts into serving these AI related
Mm.
use cases. And even if there are other parts of the businesses that are now low priority, okay, that's something that's happening. And okay, again, one of the points that they mentioned was, again, you also told about how much flexibility does the developer has about uh, how to, I mean, their concern was that they'll make every game look like the same aesthetic.
Mm.
So, so was that not the case earlier, or is it just becoming right now for the other versions of DLSS?
For the other versions, from what I understand, apart from DLSS 5, they were other versions were not completely changing the entire scene. They were not making
Okay.
any new changes. They were just upscaling it or generating the frames. Whatever frames that was generated was exactly of what it already was, just with some prediction of where the hand should move and stuff,
Okay.
so that there are more frames in between. But the physics, the art direction, etc., was not touched so far. Now they're changing the entire look of the game.
Yes, so the adding things there shouldn't be. That's what.
Yeah,
Yeah, that showed one thing. The hair, it wasn't there. Started to have hair.
yeah,
Those kind of things. Yeah. Yes. I mean, yes, because this is the point about generative AI. It like sometimes gets too creative and starts putting things. Plus,
yeah.
again, as you all know, generative AI is not predictable. Like it, I don't
Mhm.
know, it has been trained on so many things. It has its own mind and it might come up with any kind of solutions. Those are
Yeah, so that could be also one of the points, right? So when a game is designed and rendered, if a particular scene is rendered a certain way, every time you play that scene, it will be the same. Given that there are some real-time physics interaction, etc.,
Mm.
but more or less, it will look how it was designed to look. But we cannot, like the in this demo itself, maybe in it was when it was rendered for the first time, it looked a certain. Maybe the second time we are running it, there's no guarantee it is going to look the same. How do we know that generative AI is going to use the same changes it made the
Yes.
first time?
Yes. But then again, this thing, the thing that you mentioned, it reminded me of something about world models that we were talking, I think, a few months ago. But because
Hmm.
I saw one video about, I think it's about the latest version that came out. I don't remember when it was. I think probably it was December of 2025 or somewhere. So this is the exact thing that were mentioned that they have improved upon, like the consistency in the worlds for a longer period. I don't know if it was Google's what Genie or I don't know the name of the company. I'm not sure, but that's the point they were trying to make. Like, okay, now the AI has improved that it can hold that consistency of the world over time. But that is state-of-the-art world models. This is not a world model. This is just using simple generative AI. So I don't know maybe whether it will work here or not in DLSS, but for world models they have been working. That is they're claiming.
Yeah. Well, like it's still it has not been released, and so far, like Nvidia has uh, shown that they can make things work. But let's see how this actually is implemented.
Yes.
I don't really have anything else.
Yeah, yeah, I don't know. But again, like as you mentioned, there's AI kind of thing. I mean, I just recently saw a image or a graph that shows Nvidia's revenue from AI versus data center since November of 2022. Let me see if I can share this. I'll let me share this one. Can you see this one?
Yeah.
Okay, so the dark green is data center, which means mostly before AI, it was just for normal data centers, and after AI, it includes normal data centers as well as AI data centers. Light green is great gaming, and black is others. So up till Q4 FY 2023, that means I think it is oh, let me again confirm what's the financial year of February through January. Okay, so that means it's around the exact same time when ChatGPT 3 was released. That means October, November, December, and January. So this quarter is the 3 months from November 2022 till January 2023. So up till here, you can see everything is very same. I mean, dark green, the light green, the gaming part is a significant part of their overall revenue. Even though you can see the data center share of the total revenue has been increasing, but it was very linear, not that much. I think up until FY 2023, no, sorry, Q4 FY 2022, gaming was more than data. The revenue from gaming was more than the revenue from data center. I think this one, Q1 FY 2023. Now this is before the AI boom. It started to increase for the first time, but still, like they were very even, gaming and data center revenue. But just 6 months after the release of ChatGPT 3, like data center has the like by far the largest share among all the other sections. So as of the most recent, no, I think it's not the most recent. It's quite old, I think. But still, you can see, like this is 26,272 billion, and this is 2,000. That means it's 13 times more than the revenue from data centers is 13 times more than the revenue from gaming. So that's why it's no wonder they are not as concerned or as dedicated in the gaming division of their business as they're in AI.
Yeah, like from the
So
business point of view, it makes sense. It makes
yes,
obvious sense.
yes,
But the main problem here is lack of competition, because even though they are not focusing much on the gaming GPU aspect, AMD
yes.
is also not doing much better. Even now, Nvidia is the better choice for a graphics card than AMD, even though they're not focusing on graphics cards. So they have sort of monopoly position.
Okay. That is one of the question I was about to ask about all the DLSS that you have mentioned. So whether other competitors like AMD, so do they have any equivalent like of DLSS?
They have this thing called FSR,
Okay.
but DLSS is a superior technology. Maybe you can do a quick AI search comparing FSR and DLSS.
So it works on both AMD and AMD India, Nvidia and Intel. Okay. Even it says that DLSS generally delivers better image reconstruction and motion stability, especially at lower render resolutions. FSR is valued for compatibility and openness since it works across many GPU brands. So is this true? Like it also works on.
Yeah, it works on anything. Like you, even in any game, you'll have option of, if you have an Nvidia GPU, you'll have option of both FSR and DLSS. You
Okay,
can choose which one you want.
okay. But overall, DLSS is better
Yeah.
in terms of pure technology. Okay. Hmm. So that means even though like the work on gaming related hardware and technology is taking a back seat because of the AI hype, or maybe it's real. But even still, Nvidia is still the leader in this space.
Yeah.
Okay. Mm. So I think that's it. There anything else?
No.
Okay. So maybe I'll cover it next time, but I was looking into one thing about uh, talk because it reminded me, since we're talking about AI boom and so on. So over the past 1 month or so, like since the beginning of April, a lot of semiconductor related stocks have been going up a lot, like 100, more than like 200, 300% all of a sudden. So again, like this has become a big news. So look, why is it happening and so on. I think previously I just talked about Intel, how they have been happening. So if I can just briefly show what's happening. Let's start with Intel itself. So if I look at year to date means the total returns from the beginning of this year up till today. So it's 191% it has increased. It's the value of its share. Okay. And you can see for even for that 191%, up till the beginning of April, as you can see, it's 30th of March. It's practically flat. Nothing has changed much.
Mhm.
But since roughly the beginning of April onwards, you can see it's uphill. So this applies for a lot of other companies. Uh, I've been semiconductor memory, all of those companies. Like, okay, let me see, AMD is here. I'll do the same thing. Again, practically flat till here. And since March, since 1st of April onwards, it's just steep uphill. If I look at any company like Micron now, same. I think it was almost lower than what it has started. Again, still since 1st of April, uphill. SK Hynix, year to date, same pattern. Practically flat, uphill. What else? I don't know. TSMC it's happened to TSMC or not. To an extent, not that much. Another company would be the best is SanDisk, the memory company. It has gone 400% this year, but again the same pattern, similar pattern.
So
So
what was the like what caused all of this?
yes, even I'm trying to learn what's causing this kind of thing. So I don't know, like all of a sudden this occurred to me. Like I was just looking at, I think, one piece of news about how semiconductor stocks rising. And as I was looking through this, all of a sudden I captured this like pattern. Like, okay, it has gone up by a very high margin, but it's all of a sudden. It's not like through the beginning of the year it was linearly happening. It happened from this onwards. So I'm not sure yet. So I'm looking more into the details. So maybe next time I might be able to come up with the reasons why it's happening. Because it's not just one stock. I- If it was just one stock, I might be able to come up with a more logical explanation. Like for Intel, like I've explained previously, like the whole history and how it is coming, like it is having a comeback kind of thing. So maybe I can explain one stock. but like 10, 15 stocks, we're observing the same pattern. Why is it happening? So I'm looking into it. The main reasons I don't know yet, but I think so by next Tuesday I'll have at least some picture about why it might be happening. So let me just one more. So why not? So this semiconductor index SOX, or I mean this Philadelphia semiconductor index is just it like tracks the movement of all semiconductor related stocks. So that means it's the average of all the other stocks, all the other semiconductor stocks. So yeah. Anyway, I'll cover more into it the next time I talk. I just wanted to let you know that I was looking into it. Okay, so I think that should be it for
Yeah.
now.